Hi, today we will discuss about genetic algorithm in solving optimization problem. The problem is also called traveling salesman. Imagine you and your friends has recently launched franchise of bakery shop. The business went very well and demand you to expand the branches. To preserve the secret recipe, you will arrange all ingredients for every source that keep you away from focusing on developing new recipe, but spend most of the time planning for the logistics. So you decide to consult your friend who is good at machine learning, and your friend suggests to use genetic algorithm in solving the problems. The model representation is using array of data like a strand of chromosome, which each contain the possible solution. In this problem, we will represent path starting from point 0 and move to the next point, and so on until come back to where it starts. As you notice, the possible path for this small problem can be as many as 3.6 million, which is impossible to go through every single path and evaluate them one by one. This is where genetic algorithms come into help. The natural selection process has been imitated in this computer simulation. The random specimens are selected to be the parents of the first generation, sorting the best specimen and reproducing the next generation from the best specimen. This is similar to natural selection process that the good features of the parents will be blended and transferred to their offspring. Random mutation will also helping exploring and making a sample adapting to be better in the next generation. The evaluation of good genetics will be evaluated using fitness function. The specimen in the sample space will be evaluated and sorted. Only top rank will be randomly selected to be the parents of the next generation. Let's take a look at the code. The code has three main parts. Part 1, setting up the destination and transfer the latitude and longitude data into distance table for evaluating the fitness function. Part 2, generating the population and sorting the group of parents with high score. In this problem, the top 25% was selected as a group for randomly selected for breeding into the next generation. Part 3, crossover and mutation, blending the features of two random parents for making candidate for the next generation. The fitness score of the next generation will be improving. As you can see, the model population was set to 500 and the model evolution was set to maximum of 1000. This will be sufficient for our problem in reaching the optimum solution. In this example, we locate the destination as an oval shape, which we know the minimum path length will be along its circumferential. This to confirm the algorithm that we are using that provide with the satisfied result. You can also see that the feature of the previous generation is also preserved when it reaches to the optimum point. In the number of destinations are 15, which has around 1.3 billion root combinations. With genetic algorithm, we randomly populate the parents of each generation as 500 and run for less than 1,000 generations to reach the best solution. The total sample of around 500,000, which is fraction of the total possible root combinations of the population. Next, we will try to use genetic algorithm in more complicated problems. Let's say we have 3 roots altogether. The total destination of the node are 54 in this example, which implies the size of population for a possible path would be 54 factorial, or 2.3 e to the power 71. The random variable space is incredible, but the genetic algorithm with the size of population around 5,000 and 800 iterations of the generation, yet sufficient to find optimal solution, which is incredible. In this example, the k-mean clustering analysis was performed first before route optimization to grouping the node into three sections. The same algorithm is then applied for each individual cluster for finding the best route. So in conclusion, the genetic algorithm, or sometimes so-called evolutionary algorithm, can be used in solving large-scale route optimization problems. Yet the best optimal solution may not always guarantee, but the trade-off between time and complexity of setting up the problem is acceptable.